Weissman, and today I'm going to be talking about how planets move.
More specifically, I'm going to be talking about a guy named Kepler, who figured out in the 1600s a way to mathematically model how planets move around the solar system in his 3 laws.
Kepler's first law of planetary motion states that planets move in ellipses. These are oblong spheres like the one I've drawn here. In reality, our planet moves in an ellipse that is a lot closer to a circle, but I've made it a little bit more dramatic here to make my point. Now, our planet moves around this ellipse. You would think that the sun would be in the center of the ellipse, but it's actually in a point called the focus here. That leads me into Kepler's second law of planetary motion, which means that planets move at different speeds depending on where they are in the ellipse. For example, our planet is going to move a lot slower when it's here on the ellipse than when it's close to the sun right here. That's because Kepler's second law mathematically models the fact that planets are going to move the same areas in the same time. Now, these two chunks of our ellipse have the same area, and that means it's going to take the planet the same amount of time to cross them, even though the distance is a lot shorter here than it is over here. That means that the planet's going to be moving a lot faster here and a lot slower here. Now, this is so cool because a guy in the 1600s was able to create a mathematical equation that allows us to still accurately predict how planets and comets are going to move in our solar system and in other solar systems. It allows space travel to be possible, especially the Philae lander that just landed on the comet Rosetta. They sent this lander into space 10 years ago, but because of the equations Kepler came up with, they were able to tell exactly where it was going to be. They were able to land a tiny lander on a small chunk of space, hurtling through oblivion, and that's incredible.